These are the second video on the arc length. So we had seen how to derive the formulas of arc length, whether given the function as function y as a part of a function of x, again given x as a function of y. So we have two formulas on this. So as you can see, from here we'll sketch a graph to show this information. So we'll have to sketch a graph, then determine whether the function, if it's this or this. So we'll have to sketch the graph. So we'll sketch the graph. So drawing a Cartesian plane, let me draw it here. Okay. So the curve, this is the origin. So this curve, it looks like that. So okay, it's just the U curve. Okay. Let me just draw it fully. So this is what we have. The curve is this way. But for now, we're going to be looking on the negative side. So I'll just draw from here. I'll get my curve as. So that's how the curve looks like. So I'm told this is the length, this is the parabola. So we are told to find the length of the arc of the following parabola. So the parabola, this is the parabola from the origin to this point. So this is the parabola. But now I'm being given the interval 1, 1. So let me say that is my first coordinate. My first coordinate there is 1, 1. Okay? And 4, 8. So let me say this is my second coordinate. It's 4, 8. 4, 8. So I'm told find the length of the arc of this parabola. So I'm told the length that we are requiring is from here. So let me just draw a thick line from that. So this is the arc length we'll be finding the length on. Okay. So this is the arc length we'll be requiring. So we'll be trying to find the arc length for that. Okay. So from there, let's identify our function if it's either one of the two. So the function of the parabola is y squared equals to x squared. So my y alone is the same as, or it's x cubed, sorry. It's the same as the square root of x cubed. So as you can see, I'm given y as a function of x. So we have y as a function of x, it has its own formula. X as a function of y. So let's rewrite the formulas. So the formula for y as a function of x, we are told the arc length now, it's ds. For that is the same as the integral now from a to b, but where the values of a to b are the x values. Okay, so these will be the x values. Okay. The square root of 1 plus dy over dx squared multiplied by delta x, or just dx. So from this is the formula we'll be using to calculate that. So our delta x, so we said the values of a are the x values. So I'll just write here maybe to explain that. So when I'm given y as a function of x, I'll be using the formula of arc length as the integral from a to b, the square root of 1 plus delta y over delta x squared delta x. Okay? When I'm given x as a function of y, I'm told the integral from c to d, but now this will be the y value. Okay, so this will be the x, the y coordinate, but for this case, this is the x coordinate. This will be the x coordinate. So for our case, we'll be using the upper part. So we'll choose our interval, okay? The bound, not the interval. The interval. So the bound will be 1 to 4. So here I'm told the square root of 1 plus delta x now over delta y squared delta y. So I want to be using that, yes, I'll be using this. So I'll write my delta s, which is just the same as arc length, delta s or a capital L to show arc length, as the integral, okay, from a to b, where x, it represents the x value on the graph. So the x value on this graph is 1. Okay. Again to the another x to the 4th. Okay. So I'll just have my 4 here. So I'll be placing my bound as 1 to 4. Okay. The square root of 1 plus dy dx squared delta x. So from here, as you can see, let's compute our dy dx. So we said our y is the same as the square root of x cubed. So I can write that as x cubed, but now I raise it to a half. That's just the square root. So this will be the same as x to the 3 over 2, right? So I have my y as x to the 3 over 2. So I'll be finding my dy. I'll be differentiating y with respect to x. So my dy will be differentiating this, taking the power multiplying in front, we'll get 3 over 2. I'll write x again. Then I'll minus 1 from the power. So it will be 3 over 2 minus 1. So it's just a half. So I'll be getting my a half here, there. So it's with respect to x, so I'll just put my dx, that point. So I've gotten my dy dx as, I've gotten my dy with respect to dx as 3 over 2 x to the a half. Okay? So having that, I'll replace that to the formula. So we get our answer as ds equals from the interval of 1 to 4, the square root of 1 plus, now I'll be placing my dy dx, this is my dy dx inside, plus 3 over 2 x to the half, sorry, not squared, x to the half, and I will square that with respect to dx. So let's find our squared for that. So calculating our x squared, we get, so let's square this. This is the same as square root, so this is the same as 3 over 2 multiplied by the square root of x. So when I square this, I'll get square 3, it's 9, square 2, it's divided by 4, the square root squared is just multiplied by x. Okay, so I'll get my answer as 9 over 4 x. So I'll be replacing 9 over 4x inside. So I'll get my ds as the integral from 1 to 4, the square root of 1 plus 9 over 4x, okay, 9 over 4x dx. Okay, so from there we'll choose our u to be the term inside the rad, so we'll get our u. So now we'll perform the normal integration. Performing the normal integration, we'll choose our u to be 1 plus 9 over 4x. So automatically we'll have to find our du. First to replace dx. So our du will be just 9 over 4 dx. Okay? Making dx the subject. Usually say the subject, but it's not. So our dx is the same as 4 over 9. 4 over 9 du. Okay? So I'll be writing my dx as, I'm writing my dx, so this is what we have, so I'll get my ds the same as the integral from 1 to 4, the square root of u, okay, multiplied by, what's my dx? My dx is 4 over 9 du, 4 over 9 du. So taking 4 over 9 is a constant term, taking it outside the integral, we get 4 over 9. But we have changed all the expressions out, all the terms in terms of u. So we'll have again to change the bounds to the u world. So we'll get, so I'll change 1. So we said our u is 1 plus 4 over 1 plus 9 over 4, okay? Plus 9 over 4x. So I'll replace my 1 to the x, so I'll get my u1, where x is 1, I'll get 1 plus 9 over 4 multiplied by 1. So it will be just 1 plus 9 over 4. I'll get my u value for that as I'll get my u value for that as 13 over 4. Okay? So instead of writing 1, I'll write 13 over 4. Okay? Again, replacing that with 4, I'll get my u of 4th now to be 1 plus 9 over 4 times 4. 9 over 4 times 4. So I'll just get it as 10. So instead of writing 4, I've taken the interval to the u. We usually say u world, but okay, it's just u world. The 10. So this is what we'll be evaluating. So from there, I'll write my ds as the integral from 13 over 4, okay, to 10, okay, the square root of u multiplied by 4 over 9 du. So I'll take my constant term outside the integral, so I'll get my ds to be, I'll get my dx to be, ds not dx, my ds to be 4/9. Okay? The integral from 13/4 to 10, the square root of u multiplied by du. So I'll write the square root of this as, I'll take it as a power, so I'll say 4/9, the integral from 13/4 to 10, okay, of u to the 1/2 du. Performing normal integration, usually add 1 divided by the result of the power, so I'll get my answer as 4/9 multiplied by, adding 1 to the power, I'll get 3/2, so I'll get u to the 3/2 divided by the result of the power, 3/2. Okay? So that's my supposed answer, yes. But we'll have to place the bound. So like replacing with the bounds, the bound is from 13/4 to 10. So I'll write in so we'll have our answer as, so let's evaluate this. So I'll get 4/9, remember, multiplied all the integrals, so that way. So let's operate this part. Let's eliminate the bound. So I'll press my u with 10. Okay, so I'll say 10 to the 3/2 divided by 3/2. Okay, minus, usually minus this other side of the bound. So I'll say u, what's my u? 13/4. My u is 13/4. Now this 13/4 is being raised to 3/2. Okay, 3/2, and again I'll divide that to 3/2. That's my supposed answer. But I'll just continue with further simplification. So I'll get 4/9, the integral into, let me perform this. So this is the same as 10 cubed squared. So it's the same as 1,000, the square root for 1,000. Okay, divide it by 1.5. So I'll get my answer, divide it by 1.5. I'll get my answer. In terms of rad, I'll write it as 20, the square root of, okay, my answer will be 20, the square root of 10 divided by 3 minus, but again this I can just write it in terms of decimal, so it will be the same as 4/9 into, in terms of decimal we'll get 21.08 minus, again minus here, let me perform this. It's just same as 13/4. My answer is 3.25. Then I cubed that 3.25. Okay, I'll get that. Then I find my square root for the answer. I'll get, okay, divide it by 1.5. I'll get my answer as 13. The square root of 13 divided by 12. Again, that's in terms of decimal. It will be 3.91. Okay, let me just write in this 2 decimal places. So my final answer will be 21.08 minus that, so I'll get 21 0.08 minus 3.91. Okay, I'll get 17. So this is just the same as 4/9 multiplied by 17.17. Okay, I'll get my final answer. So answer multiplied by 4/9. My final answer in terms of decimal, it will be 7.631. Those are the four significant figures. I'll write it as my units. So the arc length, so the length of the curve, so the length of the arc of this parabola from that interval, from the interval 1 to 1 to 4 to 8. So my ds for that is 7.631 units. So this is my answer. So find more lectures, so find more tutorials on my YouTube page, the Professor Agui. We'll be looking on another example on arc lengths, and we'll extend the information to areas of surfaces of revolution and volumes of surfaces of revolution. Don't forget to like, share, subscribe.